Hello, my name is Neil Forcier. I'm an application engineer with Agilent Technologies, and in this video I'm going to show you and demonstrate some of Agilent's smart device instrument control programming tools. So what is a smart device? A smart device is our smartphones or our tablet PCs that are becoming more and more prevalent in our everyday lives. Now today, if we think of a PC, there's a whole host of drivers and programming tools that allow us to quickly make test and measurement software for controlling our instruments. For smart devices, this isn't the case, unfortunately. And at Agilent, we're trying to change that. So we're offering a lot of different Android and iOS programming tools for connecting to the instruments, controlling them, and plotting data. Now I'm going to start off by showing you the website, showing you some of the tools, and then demonstrating one of the tools for you. So let's get started. Okay, here we are at the web page, the Smart Device Programming Tools web page. You can access this web page by typing in agilent.com/find/smartdevice, all one word, smart device. So on this page, you can find the tools that I was speaking of. We have both Agilent I/O and Android I/O tools, as well as Android plotting tools, as well as a number of different example apps that demonstrate the use of these tools. So here I'm just going to quickly demonstrate the use of the Agilent iOS I/O library tools for controlling an instrument using an iOS device such as an iPad or an iPhone. And I'll also show an example app that uses these tools. So let me first download the tools. And then second, I'll download the example app, which the example app is called StarIDN. So let me show the tools in a folder and unzip them. So here's our I/O tools, and here's our example app. And for those of you who are familiar with Skippy commands, the StarIDN app is simply going to use an IP address to connect to an instrument. It's going to send a StarIDN command, and it's going to read the instrument's response. Now, a StarIDN command just asks an instrument, "Who are you?" And the instrument responds with its model number, serial number, and other information. So the StarIDN app uses the Agilent iOS I/O toolkit. So here I'm going to launch the project in Xcode. Let me maximize Xcode. And over here to the top left, you can see the folder with the Agilent I/O tools. There's 3 classes in there. The only class you really need to worry about is the iOS I/O class. And that's the only one you're going to reference in your program. Now, let me just quickly demonstrate this example app. I'm going to use the iPhone simulator to demonstrate it. So you can see the simulator launch. I'm going to type in an IP address to an Agilent DC power analyzer I have over at my desk. So I typed in the IP address. I'm going to get rid of the keyboard. I'm going to press connect. I connected to the instrument. Then I'm going to press StarIDN. I queried the instrument and I read back its response, and we can see the N6705B. So then I'm just going to disconnect from the instrument. So that app is just demonstrating simply the use of the library. Now, I'm just going to show you how easy it is to add the library to the app. So over here on the top left, we have our folders with the Agilent iOS I/O tools. I'm going to just delete them. And then I'm going to simply go to my download folder here, and I'm just going to slide the tool folder back into my program. It's going to ask me if I want to add this. I'm going to say yes. And we can see the folders back in with our tool classes. We can also see there's a user guide in the folder that explains how to use the programming tools. Now, if I go to my viewcontroller.h file, you can see that we reference the iOS class, which once again is explained in the user guide. I declare an object for it, which I call I/O. And then in the .m file, if I go to my viewDidLoad function right down here, you can see I declare or initiate the object. And then as I scroll up, and I understand this code's probably not easy to read, but you can see I start using it. And you can actually see here is the staridn command that I send using that class. And the idea is these tools are basically hiding the low-level sockets and the communication protocols and the buffering and the handling of the data, basically making it abstract to you so you can quickly make a test and measurement app for the iPhone without having to worry about the low-level communication. Let me go back to the web page. And we saw the tools. I demonstrated the Agilent iOS I/O tools. Also, some of these related links down here will be helpful, especially this one. This is an article that discussed controlling LXI instruments with smart devices. It explains some of the network configuration concerns you need to worry about and some of the programming concerns you need to worry about. So once again, all this is free for download, and I would encourage you, if you have any feedback, suggestions, or comments on these programming tools, use this tab right here to send an email to us. Thanks for watching.